So for the computational intelligence assignment, I built a simulation of Physarum polycephalum, which is a type of a slime mold. What you are seeing on the screen are a 500,000 tiny agent. Each is following a very simple rules, but they end up forming these complex network all on their own. Basically, none of these agents really know what is going on in the bigger picture, but these pattern emerges from their individual behavior. So now I will tell you how does it work. Each agent has its position and a direction it is facing. Every frame it does four things. First, it will sense. It has the three sensor in front of it, at its center, on its left, and on its right. It will read the chemical trail concentration at each sensor. Second, it will turn around toward whichever sensor detected the most chemical. So basically, if the left sensor detect the chemical the strongest, so it will turn toward left. Similarly, towards the right. Third, it will move toward step towards whichever direction it is now facing, and the final part is the deposit. It will also drop a small amount of chemical at its new location so the other agent can smell it and can follow it. And there is also the decay part. So decay basically fades the concentration of chemical a little bit. This makes the old trail disappear over the time so the network can keep adapting. Now I will basically show you the each parameters and how it changed the patterns immediately. First is the step size. This control how far the agent will move per frame. If I crank it up, the agent will move faster, and if I make it really smaller, the agent will move really small. If I will show you by reducing the diffusion, as you can see, it is moving really faster, but if I slow it down, the each agent will move slower. So if I make it to the normal, the second is the sensor distance. So basically, the sensor distance is how far the each agent look. If I decrease it really, they form a really fine-grained and detailed pattern like this. But if I increased it, they will form a larger pattern and the bigger and wider, as you can see on this screen. Basically, this happens due to the agent can see the large amount of data far ahead, so it will form this larger pattern due to the more concentration placed on these paths. The second is the sensor angle. This is the angle between the center sensor and the left and right sensor. A wide angle mean an agent have the broader field of view. As you can see now, it will disperse in uh, all of the direction and form a more wider network. But if I reduce it down, it will form a narrower paths as it cannot see very much far ahead in each direction. The fourth parameter is the rotation angle. It is how sharply an agent can turn. Higher value let them make a sharper turn, which tend to make the network more branchy. As you can see, as you can see, the lower make them turn more gently and creating a smoother, more flowing tail. As you can see, it forms a very high amount of trails. And configuring these different parameters make the pattern look more unique. The second is the decay rate. As you can see, by as the each agent move, it left behind a trail of chemicals. So this is the decay rate. By how much should the each chemical trail decay? If I reduce it, the more thinner trails will be removed as it will decay early. And if I keep the decay rate m1, no amount of trail will be removed and it will make a more denser uh, network. The deposit amount, basically, this is the how much the chemical each agent should drop. More deposit mean the higher, brighter, stronger trail, and the less mean the more fainter trail that will be very hard to detect by the previous agents. Let me reset it to make it more visually uh, understandable. As you can see, if I increase the deposit amount, so the you will see the more amount of trail will be deposited and it will fill more blocks. If I really reduce it, the network will become more thinner. The last is the brightness. It will increase the brightness of the each agent color. And the last is the diffusion kernel. Basically, it's apply the size of a blur applied to each pixel. As we increase it, the more blur will be applied. The other interactive features are we can change the color map of the of our network. It can form a really cool patterns and the design as each agent moves. Other than that is we can also place a series of the chemical trail by pressing the left click button and it basically placed a chemical at each pixel. Other than that, we can also place a food which is the permanent so the agent will follow it. And by pressing the C, you can change the different color maps and by using the by pressing the S key, you can take the screenshot and by pressing the R, you can reset the whole simulation. Thank you so much.